Can you guys see my screen?
Yes, Shahid, your screen is visible.
Okay, so this is our third and last session for decentralized apps. And in this one, we are going to discuss mainly about the open source projects that are currently working on. It has been headed by the team called Protocol Labs. So in the last session, we discussed how Ethereum is actually has developed various tools to build on decentralized apps. But the main concern over there was that your application has to run on Ethereum blockchain only. So that restriction somehow is not visible in the long term. So to over counter that, Protocol.ai, they basically uh, they coupled up and they build a multiple projects that we can use to build our decentralized app without actually relying on any specific blockchain technology. So one of the famous projects is the IPFS, of course. We will discuss this in our session. And the core of all this is a technology called lib2p. Now, this is the technology that is available for general purpose users as well. So using lib2p, you can build a peer-to-peer network using any programming language you sort of want, and any popular programming language, I should say JavaScript, Node.js, Go, Rust, Java is also coming up, Python is also coming up. You can use any of these programming languages to build your own peer-to-peer network. And lib2p will actually deal with all the transport layer stuff that requires, such as protocol mixing, the connection encryption, the very important, it's the native. Basically, with lib2p, you don't have to worry about whether you are using TCP or UDP or is your connection is going on WebRTC. Everything is actually uh, built on top of lib2p. So you only have to deal with building the application, not actually making your application compatible with the technologies that you are currently working on. You don't have to release a version for UDP and TCP and WebRTC. You can just release a one version using lib2p, and it will basically make sure that it is compatible towards all of those transport layer protocols. You can sort of use lib2p to build any applications, and one of the popular applications that has been built is IPFS, of course. So IPFS in turn uses lib2p only. Just a second. Neelam, you are recording the session, right? Hello? All right. Other projects other than IPFS and lib2p is IPLD and another multi-format and Filecoin. So IPLD is a protocol that manages the data inside IPFS. You don't really have to work with IPLD because it's an integrated component inside lib2p and IPFS. So, like I said, in order to manage multiple peers and maintain the same data set in all of those peers, all of these technologies, including Ethereum and Protocol.ai, they use a distributed hash table. So, distributed hash table is similar to a normal hash table. It's just that their persistence is not relied on one machine, so they are shared across, and all of the peers actually maintains a eventual consistency. So you only get, so whenever you try to read data from this distributed hash table, you only get the latest updated data. So they use, so IPLD is the one technology that has implementation of distributed hash table. IPFS is sort of combination of all of three: lib2p, multi-formatting, and of course IPLD. Filecoin is also a very interesting project by Protocol.ai. Filecoin is aiming towards incentive of the network. So suppose one of you becomes a peer and you're running IPFS peer and you're storing a file in the network, which in turn costing you some hardware space. So you can use Filecoin to basically charge for those particular file storage, and people can actually pay up to pay up as a rental store like we do in cloud or other networks. The thing is, this Filecoin is being transferred through peer-to-peer network only. It's a cryptocurrency, so there is no third party involved. Plus, you get whatever storage you actually rent out. So as of now, Liquid2P is like a general format package. So if you look over in Liquid2P for Node, so they have all of this has been built in JavaScript first. So Liquid2P JS is sort of very elemental as of now. So you can use this to sort of like create your own peer in one machine, then use the same code in another peer and pass the hash of the peers in order to make a connection. And once you are connected, you can perform various sort of communication exchanges, exchange your files and everything you want. But I would not recommend you to use this unless you want to build some custom software like IPFS, because IPFS in turn uses Liquid2P only to maintain connection and all network level stuff. So first, let me show you how IPFS actually going to look like. So if you have installed IPFS, I assume you have done that. If not, you can just simply go there, get any command line tool. I would recommend command line. And once you download, you can just run install SS. So this is a very simple step. Download the file, extract it, go to Go IPFS folder, which is the extracted folder, and run the install.sh file. Once you do that, add it into your command line so you can access your IPFS command line. So let's start IPFS. So you can do that using IPFS daemon. I'm enabling PubSub experiment so that IPFS can perform publish subscribe to another peers as well. So it's running successfully. As you can see, there are three things. First, it also runs your own gateway. So there are multiple IPs. You can connect to your local host, my local IP, of course IP6 IP. API server is running on 5001 port. If you go to API server, let's go here. You run web UI. So it will open up IPFS cluster. This is your IPFS screen. If you go to peers, since you just boot it up, it will take a few minutes in order to basically find out peers across the world and make a connection. Now we are connected to two peers in US and Amsterdam. And you can check the status here about the network traffic, how much bandwidth is being consumed out of your own peer. So after running this, your machine has become a peer in the in a vast level of IPFS network. Once you have done that, you can actually go on and sort of do file operations. So let's say you want to add some files into your network. Let me just go here. Okay. So let's say I do IPFS. Add file. Once you do that, it will return in the hash. You copy it. As you can see, we are now connected to 136 peer. To visit the file, you can just simply paste. I believe you do paste the hash. Copy it. This space. You just copy it here. Okay, the gateway is 8080. I'm sorry about that. Let me just do this. is the file that I have added. That's the hash. And, since we are running our peer as well, we can use the file live into the IPFS gateway. And you guys can do that as well. Let me just share. You don't have to become a peer to actually view the files. So this is a basic operation where you can simply add files and proper operations. And mind you, if you do delete and everything, it's a mutable thing. It's not immutable, so you can delete an operation. But whatever you do, you'll get a hash of it. So each action will be recorded into IPFS as a hash. Whatever CRUD you do, you get a hash of it, and you can use that hash to make sure that particular action has been happened. Okay. Now, let's check peers now. Another thing, the IPFS settings, you can always modify. You can change your ports, you can change the IPs. These are the bootstrap peers. Bootstrap peers are the peers that once the IPFS starts up, it basically tries to connect into these peers. And there are a few things about discovery. You don't need to change all of that. You may require to change this one and make it 000 instead of 127.0.0.1. If you want to make this particular machine where you are running the IPFS accessible from other machines into the network. It's not required if you're doing a local development. I've already updated that. Okay. So since you can add your files and everything, the IPFS becomes sort of a distributed storage for your application. But if you want to perform such as any database operations, you want an interface where you can directly build your app with, because traditionally we have in a nutshell, we have 3 layers of any application: it's front end, middle layer, and back end. Like I explained in the first session, in the decentralized apps, the front end and middle layer can be same as traditional applications. Only your data layer has to be changed to the decentralized storage, where IPFS can act as that storage. You can use IPFS with a combination of Ethereum to have every action recorded into blockchain. You can use IPFS with Bitcoin. You can use IPFS with any sort of technology. So this is completely open source and interoperable, so you don't have to worry about various technology constraints. One of the projects that has been developed on top of IPFS and is very popular is OrbitDB. So OrbitDB, like name suggests, it's a database project. It's a serverless peer-to-peer database that runs on top of IPFS, and it uses IPFS PubSub to actually synchronize these databases running in multiple peers across the world. They use all the good stuff: eventual consistency, CRDD for complexity. I believe you can Google all that to learn it. So consistency model of distributed computing has been adopted into OrbitDB and IPFS as well. And they provide multiple sort database types. You have log database, feed, key value, top. I have developed one small application as a demo application. I will show that to you how we are using docs as a storage engine for our application. Another popular project is Bigchain D. It's sort of a blockchain database. It's not based on IPFS. They have basically built their own blockchain, and you can basically use the blockchain as a database. It's a little different concept than any other thing we want, because the way these guys have built it is that whatever you store in your blockchain would be an asset, be it your user connection, be it your transaction, be it any physical thing such as house, chair, car, bike, whatever you can virtually describe as an asset has to be identified as an asset. That asset can be later used as a model on which the transaction can be performed. Transaction could be anything, could be transfer of asset from one account to another, could be purchase of the asset, could be putting the asset onto the sale. So, or could be just storing the asset into the chain. So you can use the blockchain DB to sort of do whatever you want But the only constraint here as well that they have their own network. So your whole application is actually dependent on the network provided by the Bigchain D. Okay. So along with libqtp and IPFS and with OrbitDB, you can sort of build an application that uses the traditional front-end and middle layer, but the modern distributed file storage or distributed storage system. You can combine this with Ethereum chain to actually have a complete, fully fledged decentralized app that is using distributed file system along with blockchain to actually have a trustless system. Let me show you the application that we have built. Let me put that up first. You're running IPFS. The application that we have built is decentralized email. So we are using OrbitDB and IPFS to actually build a peer-to-peer email system. So in a traditional email system, like we have SMTP, client, to actually transfer our email from one server to another, and then it goes to your client. What I figured out that since in a decentralized network, everyone actually shares the same data, and whole network is maintaining the same state, we can use the same state management to actually build an email application. So whenever any changes has been made, or whenever someone send or receive an email, that particular changes are replicated across the network. So you don't really have to use SMTP protocol at all. Decentralized email also uses a public and private key encryption. So your email is actually encrypted with the public key of the intended receiver. So only the receiver who has the private key associated with that public key can actually read the email. Plus, you can only send an email to the people whom you have your public keys. If you don't have public keys, you can simply do not send an email at all. So this sort of solves the spam problem that SMTP has, because an SMTP has the address of anyone, you can just simply send an email. We tried to tackle that problem using the private public key encryption, and of course using the decentralization to maintain the data state across every node. So let me first log in and show you how it actually works. Hold on, okay, here. All right. So we can, it looks pretty similar to traditional application. This is normal front-end bootstrap application. You can compose an email, you can send, we have sent one email, you can check your contacts, you can request someone to basically add someone into your context. First, you need to send a request. Once the intended party accepts the request, then only both of you actually become a contact, for example, here. And once you have the contact, both of the user can actually exchange emails between them. And the email that you compose is actually first encrypted with the public key of the receiver and the private key of the sender, so that only the intended receiver can actually decode the email. Let me show you how to actually decode an email when you log into another account. So this is a sort of simple email that has been sent. You can see the hash. This is the IPFS hash. And you can respond to an email and all the basic thing you do with an email. Once you do that, basically the replication happens. So if you have multiple pairs, you will see that the replication is completely happening in the database. And that replication is actually what makes our application work like an email one, because we actually share the data across like SMTP does. Instead of SMTP server, SMTP client, we have a decentralized peers that are sharing the same state and same data. Then we'll log in with the this. You see, we got the share, and that's pretty much it. This application does. Let me show you guys the code of that and how we actually have built it. So this application is built with, like I said, traditional technologies are normal front end. Middle layer is our Node.js that interacts with OrbitDB and IPFS, and IPFS and OrbitDB maintains the database connection. Since we want this application to be peer-to-peer, the database addresses, which is this, has to be shared in every single peer. So the first peer, which we can call Genesis peer, once you run that application, we actually check whether this file exists or not. If it does exist, we simply make a connection to that database from other peers and copy the database. But if the file does not exist, we assume that this is a Genesis peer, and we actually create a new file. We can check that logic here. These are all the modules that we are using: OrbitDB, Bcrypt, identity provider, and everything. The first thing we are doing is we are making a connection to IPFS. Then once the connection has been made, we are trying to load the database into our memory. To do that, first we are checking if we have the file or not. If we don't have the file, then we assume that this is a Genesis peer. That means this is the first peer. So we create a new database, user context and everything. We are using OrbitDB and docstore data model. Docstore data model is very similar to MongoDB data model. You just store whatever JSON you want into particular data store. We are making write to everyone because we want other peers to actually make a write request, so that once someone else makes a change into the database, this particular peer can also replicate things. And once the database has been created, we are just taking the addresses here and creating a new file. That file looks like this. This seems familiar with the IPFS hash. That's the name. But if the file already exists, we simply read the file and we open those into our memory. And these are the following events that are required to check whether the database is getting synchronized with our database or not. In order to have this synchronization, we have to run IPFS with pops up experiment mode on that I have shown you here. Similar like that. Okay. And once everything is sorted, we simply load the database. And once the database is loaded, you can perform all the operations. Let me show you how we actually encrypt the database. Okay, first thing first, whenever someone is doing a sign up, we are taking all the database, the information we like, email, password, and whatever. And we are creating a public and private key addresses for them. The way we are doing that is just simply using a asymmetric crypto module, which uses the SHA-256 module to create a public-private key pair out of random. These pairs are then stored into a database, and we use that to actually do the encryption. We are storing the private key with the final encryption in order to make sure that no one can actually steal the encryption private keys of someone else. Once you do that, you can simply sign that particular email. Say here we are creating a new email. Sorry, it's in the db.js. Okay, here. So once we check whether this contact exists, these are all normal logic. This is where we sign our email. What we do, we pass the sender's private key and the recipient's public key, and we encrypt the email data with it. And that is then stored in our database again. And once someone receives that, which is here, All they have to do, they have to first verify whether this email is for them or not, and then simply they can just simply decode the email. That happens is using this. We pass the signature of the email, we pass the sender's public key, the private key of the intended receiver. And that's pretty much it for the logic. Sign is this, where we are using asymmetric crypto encrypt module using the public key private key pair to sign any data you want. Verify is also pretty much the same. And database is using RBTP. So each peer is having their own database, which looks like this. And these databases are then particularly shared. So if you created your Genesis peer in one machine and you want your another peer to actually share the same data, all you need to share is these content, which is db.js address. So once they boot up using these database addresses, their system will not create a new database, but in turn loads it from your own peer so that they have the same copy of data. And that's something pretty much it. So this is the app that we have built to actually demonstrate how we can build a decentralized app, fully fledged decentralized app using the technologies that we are all right now and the new technologies such as IPFS, OPTB, and other types. So let me know if you guys have some questions. Okay. Nilam, I think I'm done here. If anyone has any questions, they can proceed and ask me later. Check the
I
comments.
Hello Shahid. I had just one query. Like in the very first session, you had mentioned that although the blockchain applications, like on the security perspective, it's very tight, but there are still some cases wherein it can be hacked or the data can get leaked. Can you share that information again? Because I'm trying to remember what you stated there, but I can't recollect it.
So what happened actually that let's say let me just show you a news right. So generally when Bitcoin basically came up, so the network is itself is very secure. So whatever data you basically is been transferred into the network is very secure, and even if it's public, it's very difficult for anyone to actually uh, take out the whole chain and decrypt every encrypted data. I mean, you need very advanced computer, probably a quantum computer, to actually do that. But still, there are a lot of theft happen. Someone stole Bitcoin of someone else's. The way that happens is that the people who actually hold the Bitcoin, or in this case, the exchanges which actually hold the private and public key of each user, their infrastructure is not secure. So if any hacker actually holds the private key, then basically he can access your wallet, he can make the transfer to their own wallet, and that's actually a valid operation. Saving your own private key is way more important than it's consider private key like a very strong password, and make sure it actually has to be very secure, because once anyone has the access of that, or you can forget your money because they can simply transfer it, and once it is transferred, since the whole chain is immutable, you can't actually make a reverse transaction at all. So that's one of the possibility of stolen money, which you can say hack as well. Another hack that is possible. It's called 51% attack. So with this attack, what happens is that you can see a group of miners who controls more than 50% of the hash rate, the mining rate. They can actually take over the network and actually can do whatever they want to, because that's 51% of the peers that they actually own. So once they do that, they on the any concessions that happens, any voting that happens into the network, they can either deny or they can accept. simply say no or simply say yes and make whatever decision they want to. So this is another possibility of attack. But the way Bitcoin actually handles it, that requires a lot of money, right? So instead of doing that, anyone can actually become a miner with that amount of money, with that amount of advanced hardware, and can actually earn more money than just owning the network. And mind you, by owning the network, you don't actually own the money at all. You can, however, reject someone's transactions, but you don't own everyone's money. So that's thing, another way network can be attacked. If you talk about DDoS and everything, then that's not possible as of this moment. The reason being that they already have a time-based constraint on transactions. So Bitcoin only approves one particular block per 10 minutes. If you have a million blocks lined up, it won't actually affect the network at all because it will only take blocks for 10 minutes. That sort of a thing that has been already handled. So traditional way of hacking uh, data is not actually applicable in Bitcoin, especially because Bitcoin is really very secure. But of course, you can use another ways such as 51% attack, sniffing, or basically spamming other users to get their own private key and all those stuff which has been going on currently as well. Did you get the? Did you get my point?
Yes, yes, yeah. Thank you.
Okay. Yeah. Okay. Anyone else?
Guys, anyone else who would like to ask any question, or we can wrap up the session? Okay, sure. Shahid, I think we are good to go. Yeah?
All right, Neil. Thanks.
Thank you.
Thank you
Thank you
everyone
so
for
much,
joining.
everyone.